Welcome to the Woodland River Market. Out here, a fox crossing stepping stones or otters sorting shells represent real situations with set prices, fees, and totals that we can turn into mathematical equations. When we need to figure out a missing amount, we have to start with the final total and systematically undo the steps that built it. Take this trail. A fox has a path that is 26 stones long. 5 stones are already behind him, and he plans to split the remaining path into 3 equal hops. We can model this exact constraint with an equation. 3x plus 5 equals 26. Establishing a clear equation is the crucial first step. It takes the physical constraints of the trail and gives us a literal path we can walk backwards to find our starting point. Looking at the 3 and the x, it is tempting to jump straight to dividing, but the multiplication is glued tightly to the variable. To untangle this, we have to remove the loose added amount first. We subtract 5 from both sides to clear out that constant. The equation updates to 3x equals 21. Now we can handle the multiplication. We divide the remaining amount by 3, splitting the path into equal chunks. X equals 7. That is the reliable sequence for a two-step equation. Always undo the added or subtracted amount first, then undo the multiplication. Down at the riverbank, otters are organizing a total of 28 shiny shells. They place them into 4 woven baskets, with every basket holding an identical bundle of x plus 2. The equation is 4 times the group x plus 2 equals 28. Because we see parentheses, distributing the 4 is usually our first instinct. There is a more efficient strategy. Treat the entire group inside the parentheses as a single trapped box. If we divide both sides by 4 right away, we isolate that entire group. X plus 2 equals 7. Looking at x plus 2 equals 7, what is the exact final mathematical move needed to get x completely by itself? We subtract 2 from both sides. X equals 5. When variables are trapped in a group, dividing out the outside multiplier first is the cleanest path to a standard one-step equation. Over at the ticket booth, a woodland owl is managing admissions for a museum. The museum charges $3 per student, plus a $12 fixed booking fee. The total bill for a visiting group is $45. We need to figure out how many students went by mapping these constraints to an equation. The rate is the $3 per student. The fixed fee is that one-time $12 charge, and the total is $45. Putting those pieces together gives us our equation. 3s for the students plus 12 equals 45. We walk backwards by taking away the fixed booking fee first. Subtract 12 from 45, leaving 33. The equation is now 3s equals 33. Finally, we divide that remaining total by the $3 student rate to isolate s. S equals 11. Interpreting that back into the real world, exactly 11 students attended the museum. Define the rate as the multiplier and the fixed fee as the constant. Build your equation and systematically undo the constraints to find the truth.